Have you ever just stopped and wondered how your phone knows things? How an app decides what to show you next? I'll tell you right now, it's not magic. It's actually a kind of secret language, and it's built from a few surprisingly simple rules. And today, we're going to pull back the curtain and learn how to speak it.
Yeah, it all boils down to questions just like this. Behind every single login screen, every game over message, every notification that pops up on your phone, there's a computer making a decision. It's a fundamental process, and we're about to see exactly how it works.
All right, so where do we even begin? Well, like with anything complex, you gotta start with the smallest possible piece, the first building block. Before a computer can do anything complicated, it has to learn how to do something incredibly simple. Just make a choice. So, say hello to your new best friend, the if statement. Think of it like this. If it's raining outside, then you take an umbrella. That's it. It's a one-way decision. What if it's not raining? Well, then you just don't take the umbrella. Simple as that. The action only happens if that if condition is true. And here's what that logic looks like visually. See, you ask a question and only one path, the true path, actually leads to doing something. If the condition isn't met, if the answer is false, the computer does, well, nothing. It just skips right past that action and moves on. This whole all or nothing idea is the very first step in controlling how a program works. And here's how that looks in actual code. That first line, if number greater than 0, that's the computer asking the question. And that second line tucked underneath it, that's the instruction. And that instruction is only carried out if the answer to the question is yes. If the number is 0 or less, the computer just completely ignores that print command. Okay, so a single choice is a good start. But let's be real, life is rarely that simple, right? What if we don't want the computer to just do nothing? What if we want it to do something else instead? For that, we need an alternative path. And here's the solution. We just add an else statement. And suddenly, it's not about doing something or doing nothing. Now it's a real choice between two different actions. The program gets to a fork in the road, and it's forced to go one way or the other. There's no more just skipping past. So here's the key takeaway. With if-else, the program is always going to do something. It follows one path if the condition is true, and it follows a totally different path if the condition is false. The program no longer has the option to sit on the sidelines. It has to make a choice. Now, this is where things get really powerful. A simple yes or no is good, but what about situations where you have tons of possible outcomes? How do you handle those? I mean, just think about assigning a letter grade on a test. You've got A, B, C, F. That's at least 4 different outcomes, all based on one number. A simple if this, otherwise that setup just isn't going to cut it. So how do we deal with this? Well, we just create a chain of decisions. The computer asks the first question. If the answer is no, it just moves on to the next one, and then the next one, and so on. It's kind of like a waterfall, just flowing down until it finds the one right path to take. We call this a decision ladder. The program starts at the very top rung and checks the first condition. If it's true, awesome. It does its thing and then jumps off the ladder completely. If it's false, it just moves down to the next rung and checks the next condition. It keeps climbing down until it finds a match. It's a really clean, elegant way to handle a whole bunch of different options. Okay, making decisions is one thing, but what's the real superpower of programming? I'll tell you, it's repetition. It's making a computer do the same tedious task thousands or millions of times perfectly without ever getting bored. And this is called looping. And loops really come in 2 main flavors. You've got your definite loops, which run a specific number of times. Think, check the first 10 emails. And then you have indefinite loops, which run until a condition changes, like keep checking for new email until I close the app. We're going to start with that first kind, definite loops. So this is the anatomy of what's called a for loop in Python. It's got 4 simple parts. The for keyword, just to kick things off, a variable that acts as a counter to keep track of which repetition we're on, a range function that says how many times to repeat, and finally the indented body of code that actually gets repeated. Okay, let's see it in action. That line for count in range 4 is just an instruction to do something 4 times. The variable count keeps track of which lap we're on, and here's a fun little quirk for you. Programmers almost always start counting from 0. So a range of 4 actually gives us the numbers 0, 1, 2, and 3. All right, now for a little insider secret. This is a really clever trick that computers use to be more efficient. And it's a fantastic example of how programmers can write smarter and much safer code.
It's called short circuit evaluation, and basically, it means the computer is lazy in a good way. If you have a condition that checks A and B, and it checks A and finds out it's false, it doesn't even bother checking B. I mean, why would it? It already knows the whole statement has to be false.
Now, this isn't just about speed, it's about safety. It's huge. Imagine that first check, count greater than 0, is like a gatekeeper. If count happens to be 0, the gatekeeper stops everything right there. The computer never even gets to the second part of the code, where that division is waiting, which would cause a division by 0 error and crash the program. By putting a simple safety check first, the computer never even attempts a command that could break everything.
So let's just bring it all together. We started with these tiny, simple choices, and we ended up with smart, efficient loops. And it's these fundamental building blocks, just stacked one on top of the other, that create every single piece of software you have ever used. Think about what we just learned. We started with a simple yes or no. Then we added branching paths, creating forks in the road. We built entire ladders to handle lots of different options. And then we gave the computer a superpower: repetition. This is the grammar of code, and it lets us build entire worlds from just these few simple rules.
And this isn't just some niche skill anymore. As the great Stephen Hawking said, understanding this kind of logic is absolutely essential in the 21st century. It's a tool for problem solving, for creativity, and, for building the future.
Every app, every website, every breakthrough you see in AI was built from these exact rules. They are simple, they are powerful, and they are accessible to everyone. So the only real question left is, what rules will you create?